In this lecture, we are going to talk about the concept of hypothesis testing and one approach of tackling this problem. So problem, hypothesis testing, and one solution out of many called maximum likelihood. Let's start with the intuition of hypothesis testing. So the problem statement is you have a couple of guesses and you want to determine your best guess given your observations. So determine best hypotheses given that you have observed, let's just say given your observations. An example would be, given that I have observed that the ground is wet, is it more likely that this morning it was raining, rained, or is it more likely that it was sunny? Now, given that intuition, let's try to formalize this some more. So the concepts in hypothesis testing are these three entities. One, you have observation. Some other texts might use the word data or evidence. Then you also have your models that you are considering. Some people say models, some people say hypotheses, others say guess. Finally, you also assume that you know the conditional probability of the observations given your guesses. So given your model 1, and you also know the other conditional probability for the second model. Now, given these concepts, how do we relate this to the previous example? So the observation would be ground is wet, and the first hypothesis is it rained, and the second hypothesis is it was sunny. And furthermore, you know the probability of the ground being wet given it was raining, and you also know the probability, conditional probability, conditioned on the second hypothesis, which was when it was sunny. Okay, and your goal was, is H1 or H2 more likely? And how do we do this? How to do this? Maximum likelihood is one such approach, and what it does is it says pick model that maximizes the likelihood function. Now, I haven't defined what the likelihood function is, but it's this guy, probability of ops given model. So let's go through, continuing our previous example. If we have the following likelihood data, probability of wet given rain is 0.9, and probability of wet given sunny is 0.2. Since the first probability is greater than the second one, we then guess rain. Now let's rewrite what we just said in terms of math. So what we have as a problem statement are x, the observation, In this example, we just have ground wet, but in the following examples that will be saved for other lectures, we can see that x can be a scalar value. And then we also have theta, your list of models. So you have sunny or rain. And finally, you have the likelihood functions. Probability of observing this x, given that you assume the model in use is this theta. So this is likelihood function. And your answer, if you were to use maximum likelihood, no surprise here, you are finding the theta that maximizes the likelihood function. And if you're not familiar with the syntax, argmax means give me the theta that maximizes the likelihood function. Okay, let's recap what we have learned in a few lines. We have this in this problem of hypothesis testing, where you have to find the hypothesis that is most likely given your observations. One approach out of many to do this is called maximum likelihood, where the math is like so. Now, next steps. In the following lectures, we are going to look at examples in the discrete and continuous settings, and not discussed in the lectures, but if you're curious, why is it that we are maximizing this likelihood function as opposed to maximizing the other way around? The second approach is called maximum a posteriori estimate. Max a posteriori estimate. And it's out of scope for this class, but if you want to know more about this, let me know in the office hours.